Hey guys, welcome back to another video. So today we will be solving another problem on greedy. So let's try to code this problem. What does this problem says? You are given an integer array nums. Okay. You are initially positioned at the array's first index and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. If you can reach the last index, then you have to return true, otherwise return false. Let's start from here. You can jump like 2 or 1. I think 1 would be better because you are getting 3. If you jump 2, you are getting 1. You jump here 1, getting 1, 2, 1, you're getting so 4. Hopefully this will work. That we have to jump to the maximum which we can find possible. Like compare it or something we're gonna use. See here you see 3, 2, 1, 4. You can jump 1, you can jump 2, you can jump 3. But if if you jump 1, then there's 2, 2. Done. Nothing is done. So if you jump 2, then also if you jump 3, then also there is no ways to solve this problem, if you can see that. And okay, it can be solved by DP also, I think so, because we have choices to take. I have understood the code. Let's try to see it and solve this problem on our by ourselves to see how the problem, like optimal approach. Let's see. Greedy algorithm makes a series of choices, each of which looks the best at the moment, with the hope that these local optimizations will lead to a globally optimized solution. The key idea is to make best possible choice at each step without considering the overall problem. Okay, best possible choice is taken first of all. For this problem, we keep track of the furthest position. We, okay, like n, we can reach at any point in time. At any point in time, we iterate over the array and keep making greedy choice of reaching the farthest by comparing if the current index can be reached by the previous indices or not. Track of the furthest position we can reach at any point in time. So the furthest point we can reach. We have to iterate over the array and keep making greedy choice of reaching the farthest by comparing if the current index can be reached by previous indices or not. If we can reach an index that is beyond the farthest position we can reach, we return false. Else we keep updating the furthest position with the maximum index we can reach from the current index. Okay, hopefully I didn't understood. Step 1, initialize variable max index to keep the track of the farthest index we can reach from the start. Max index. Okay, current index is 0. Farthest point we can go is 1. Iterate through each index of the array add and at each interaction check if the current index is greater than the maximum index. The current index is 2, is greater than the maximum index. Uh, okay, we can reach so far. If the current index is greater than the maximum index, it means the current index is not reachable, hence we return false. What does this says? I didn't understood though. So we have max index, which is the maximum of current index and how much it can go. Got it. It can go, let's say, up to 1. The current index is 0. So 1 would be the maximum index. Yeah. So it can go up to 1 index. Got it. Now current index is 1. Here you can go to up to 2 index. Current index is 1. Okay. And the maximum of current index, comma, what? I think 1 and 0 it would be like. No, sorry, 1 and 1. That's how you're getting 1 now. And current index is 2, let's say. So 2 and I think I didn't get it. Um, oh, okay. Like the index 1 and 3. 2, 2 and 5. What is this? What if the current index is not reachable? What is the maximum index? Farthest index we can reach. Okay, 1 and 3. Uh-huh. Um, farthest farthest index we can reach from the start. From the start, how much we can reach. Okay. Like if you see this example, you can reach up to 1. From the first, you can reach up to 3. Mm, From the start, you can reach up to say 3 na. So is 1. full. Okay, in 3 we can reach up to 5. From 5, farthest point you can reach. The goal is to determine if we can reach the last index from the first index. Obviously, since each other presents how far each number each number represents how far we can jump. We need a way to track the farthest point reachable as we go. Okay, we need a variable to see whether how much we can go. It's like this or something. Take example of 2 3 1 1 4. How much farthest we can go, that we have to track. Approach: use a greedy strategy and keep the variable maximum reach to store the farthest index you can reach at any point as we iterate through the array. There you are at the first. You can farthest you can go is 2. At this you can farthest go at 3. Okay. Yep. As we iterate through the array, if the current index is greater than maximum reach, it means we are stuck and can't proceed. Current index, let's say. Mhm. The farthest 1, 2, 3, 4, 5, 6, 7. Okay. Farthest you can go is 4. Current index is 4. Otherwise, we update the maximum reach to the maximum of current value and I plus mac items of I. Okay, maximum reach and I plus nums of I. If we can iterate through the entire array without getting stuck, we can reach the last index. Yeah, yeah. So what do we do? We just, we just, let's take an example which is not possible, otherwise it will not be useful. 3, 2, 1, 0 and 4. This is the array we are talking about. Here we can see we can't reach. Okay, so what we are doing is that we are greedy approach. What is the greedy strategy? We are making a maximum, like maximum we can, how much we can reach. Here you can reach 3 up to 3, which is at the 0th index. Okay, maximum reach I plus nums of I. This, yeah. Now you are at the first position. You can reach up to 2. Okay, If I is greater than maximum reach, it means we are stuck and we can't proceed. Otherwise, we update the maximum reach to the maximum of its current value, which is 3, and I plus 1 plus nums of I, that is can reach up to, let's say here also you can reach up to 0, 1, 2, 3, 3 only. So the 3 will be our answer only. Maximum reach. Okay, maximum farthest most. Okay, I got it now. I got it now. Now you are at this position. You can maximally reach up to 1. Let's say the position where you can reach is 4. No, sorry, 3. 3 position you can reach up to. Okay, because 2 plus 1 is 3. Correct. And the maximum reach also here 3. Now you are at the this position, which is 0, 1, 2, 3, third position. Okay, and the maximum reach here is 3 only, and plus I plus, yeah, I see. So I plus now, so I is 3 only, and okay, 3 will be the maximum reach. Now you have here, and the I is obviously greater than the maximum reach, so you can't reach, you are stuck. Maximum reach is this. If you are at the index which is greater than the maximum reach, that means you can't go there. It's impossible. Let's take the example which is possible. Now you are understanding this topic. Okay, what we are doing? We're just keeping the maximum reach, like how many positions you can reach. In this index, obviously we can reach up to 2. Like here you can reach, yeah, and you are here. Now we can reach up to this. Now you are here, you can reach up to uh this, but the maximum reach will be this, and again this, then this, and then out. If any of the time you get more, like the max I is greater than maximum reach, that means you can't reach. If it is you come out of the loop, that means you have already traversed it and it didn't false, that means it is true. Okay, let's code it. Understood. Pretty simple though. Not very simple, but it is thinking first time is a bit tough. How, like what we done? Let us write it in my notes, so that I could remember this concept. That what is the problem? It is the jump game. Okay, jump game. And in this problem, what it does is that we have an array, okay, and it has some maximum we can go, yeah, and return true if we can reach last. So what you have done? We make a maximum reach position, uh, a variable में if I is greater than this thing. If anytime you see that I is greater than the maximum reach position, that means stuck. False return. And there is also possibility of that after the loop return to. I think hopefully it is gonna work. Let's make a n also. N is also needed. N is nums dot size. Maximum, maximum. Let's a position. We make a position because we're not in the maximum we can reach. No, it's the maximum position we can reach. Maximum position we can make. So which is the maximum of. Oh, I need ISO. Just make it, and we need a for loop which is gonna start from 0, I less than n, I plus plus. If 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 let us mm, maximum position. Okay, maximum position is needed here at first because you are at position. You need the maximum position you can reach. Okay, here you are. You need the maximum position. Also, you are checking that if the if the I is greater than the maximum position you can reach, that means return false. Also, there is a uh, position we were finding which is not in my bound. Uh, let's say we are at the end. We can say we are at the end. I think first of all we should check. Then what we should do first? Whether we should make a Mac before or after, because it is very important. Let's think of if we first add maximum position we can reach. Okay, if we first add the maximum position we can reach, then what happens? Then if you are at the last position, so you are putting the maximum position we can reach, and I is 4, obviously I will be less. This one is for the before, so we will make it here only. Nums 0, yeah, let's say plus, first of all obviously 0. So if max position I is greater than max position we can reach, then we uh yeah, yeah. Oh, okay, so return false. Else it's equal or something, max position will be I plus nums of I, I index plus nums of I, and then return True. If we are out of the loop. Yeah, it's going to be this thing. What? So now the edge cases is there. It's 200. Okay, so it's returning false, but we can reach obviously. 0, next position. It's 2 and it's not greater. Maximum. We need the maximum of this, comma, previous. Why did I do this? You wanna ask? Because it will have the another. Yeah, see, if you can see this, you can pass. But for here, if you come here, you can't pass. That is why you should please pass the maximum of it. How many you can pass? Like this much you can pass, and this much you can pass. You have come at the end, we can say, reached the position you want to come. You were stuck, and if you are no, there is no problem. I is not anytime is not greater, and means you can reach the position that is the maximum. I plus, why do I plus? Because we are counting from that index to that, this plus this, that is why. Hopefully it is understandable what I'm talking, what I'm telling. It's pretty simple though. Nice question. Okay, now let us move on to the next problem, which is the, what do you call, the abbreviation of the previous one, like the more complex version of this previous one. So what does this problem says? Let's read. So jump game 2. You are given a zero indexed array of integers nums of length n. So we have a zero indexed array of integers nums of length n. Okay, you are given a zero index array of integer. Okay, okay, okay. What? In each element. So I represent the maximum length for jump from my index. In other words, if you are at terms of I, can jump to any. Okay, and got it. Written the minimum number of jumps. Minimum number of jumps. Okay, optimization problem obviously. Minimum number of jumps it is asking to reach the nums of n minus 1 position. the test case are generated such that you can reach n minus 1, numbers of n minus 1. If you jump 2 plus 1 plus 1 plus can reach, but it is lots of too much time you are counting. But if you jump here and 1 and direct 2, so 2 number of ways is the minimum number of ways jump to get up to here. If you do 1 2 3 2 jumps, so 1 and 2 2 jumps, so we have to minimum number of count here is needed, the count. Okay, like number of the count minimum number of jumps to reach the last index. It's guaranteed that you can reach. Okay, length is 10 to the power 4. Okay, obviously it is a greedy approach because choosing the maximum one, here you don't need the what do you call, here you don't need the maximum whether we can reach or not. You can reach, here you do not need to return true or false whether you can reach or not. Here you can, you have to return the count, number of count. Here dp is probably very useful because choosing the minimum number of guys, minimum of this and this, can use that. I'm thinking of greedy approach. It's a greedy problem we are solving. Okay, so how to do this? So we have 2 3 1 and 1 and 4. We are at the index 2 and index 1. Now we iterate, can go up to 2, go up to 1. Okay, yeah, I thought it was good that to count, to keep the maximum frequency, maximum distance we can cover, and if it is greater that means we are out of bound and we can't reach that. It's true false. Here you need to count how many way, I mean, how not how many ways, the count of minimum number of counts to reach the destination. To solve this problem, what I can think of, I'm not able to, like, my mind is closed because the count is needed now. So how I'm gonna approach this? I need to get into the maximum, let's say maximum what do you call element, then another maximum element. Here also if you see, to reach the maximum element, then maximum element, though it makes me uh suffer. Okay, uh, for count we do plus sign because what I can do, bro, this is uh if you reach uh like the maximum you can say, and it's up to 2, it's up to 3. mm. When we should increase the count, obviously we need a count which will be plus plus, but when take, we have two choices whether to take this or take that, which is maximum I will choose that. I think that is the algorithm which is gonna use that the maximum one. Like if I choose two, if I choose one, which has the maximum uh, nums of I, so I will take that and count increase will increase the count, and then again we will see the maximum whether where like one, then two, then three. Not able to think, not able to think. Keep near and far position and get to the farthest position. Keep near and far position, get to the farthest position. What? Yeah. Yeah. Obviously, this time complexity is big of n because we are moving only n time. It's a very good approach, optimized, we can say. We can say it is optimized approach. But now, this problem, what is the thing that is making uh, so I eat something. You have to eat something, or every time you have to eat something. Not able to solve properly. What I'm gonna do? Yep, it's that furthest position. Okay, from previous jump position is not always following the next furthest position. For index 0, furthest position should be index 2. Yeah, because maximum jump from 0 is 2. But if we jump from index 2, can jump to the next position. If we jump to index